Bismillahirrahmanirrahim. Assalamu alaikum. My name is Jamshaid. So today we are going to discuss about the central processing unit and the structures inside it. So first of all, we have four devices inside the CPU, which is known as program counter and the instruction decoder and arithmetic logic unit and registers. Program counter is used to point out our instructions which we are performing to the next, and the instruction decoder store and display our instruction which is performing during our operation, and this arithmetic logic unit performs all of our arithmetic operations, and registers are used to store all of our memory inputs or outputs. So now we are going to move towards our some simple code. As you can see, such as we have to perform this. So first of all, I'm gonna perform the first operations, which is zero operations. So when I'm not performing any operations, so my program counter is at 0 because it performs zero operation and move to next. So such as I am not performing any operation, then it is 0, and if I am performing zero operation, then it will move to 1. So it points out our next instruction. So such as I'm gonna perform the first operation, such as 0. So for performing zero operations, I have to store 31 in instruction decoder. So now you can see, if I am performing zero operation, then my program counter move towards 1, next instruction, and instruction decoder stores 31. So my first operation is that we have to move 17th operation to A. So such as I have a unit or any number such as 9 in 17, then it moves towards A, such as this A registers. And now the next operation is that we have to move this A to the B. So in next operation, final A is moved towards B, and after this I am performing first operation. So when I am performing first operation, then my program counter moves towards 2 because it shows our next operation. So in instruction decoder it is now stored. So now if A move towards B, and then from our sixth memory my data is recorded to the A. So it is 5. So 5 plus 9, 9 is already stored previously, so 5 also moves to A. It means 5 plus 9 is equal to 14, but in hexa we have E. So in hexa it writes as E. So I am performing fourth operations, which is EA in hexa. So the program counter shows 5. So the operation which is known as A plus B approaches to A register is performed with the help of this arithmetic logic units. So these 16 input IO devices such as 16, 17, 18 are used to display or passes address with the help of address bus, and then the data is moved towards the register with the help of this data bus. So this is the basic arithmetic logic of unit operation, program counter, instruction decoder, and registers with the help of this structure of central processing unit. So now we are going to talk about the AVR microcontrollers. So as you can see, here is a 8-bit AVR microcontrollers which we prefer mostly. So if we discuss about the AVR microcontrollers, then we can easily know about the PIC, HCS 12, 8051, all these microcontrollers. So we have to prefer AVR. So if I'm going to discuss the AVR internal architecture, so as you can see, it consists of a program ROM, program the CPU, which has arithmetic logic units, program counter, instruction decoder, and registers, etc. And here is a oscillator and interrupt unit, ports, other peripherals, RAM, random access memory, EPROM, easily easily programmable read-only memory, and there are some timers and other peripherals. So our code which we have to perform is stored in this program ROM. So here is a bus system. So these RAM consist of code which is temporary. When we have to shut down our PC or shut down our all the system, it will lose all of our stored data. Here is a oscillator, and here is a crystal which is used to give a range of frequency. This is have a great role in our microcontrollers, and it is also used for maximum 20 mega. There are some ports which are usually bidirectional, these are used to get data from the all the sensors, LDRs. So that's why these are really used, and these are some timers and other peripherals, and these are the interrupt units. So interrupt units performs actions such as we have to perform the one basic task. To perform this basic task, we have to stop the other operations. So interrupt units plays a role to stop this system, such as when we are using our computers or our PCs, such as with the help of keyboard and mouse, we are performing all these operations. If our keyboard or mouse is not operating, then our system will not stop, it will goes on. So these interrupt units are also plays a role in AVR, as this like as for interrupting the function to perform the first one basic or important operation. So this is like our AVR microcontrollers. We can also get all of our information from its data sheets, ground, VCC, and all other ports. So these are some groups of AVR microcontrollers: mega groups, tiny groups, special purpose AVR X mega. So these depending upon the operations, depending upon the features, we can use AVR microcontrollers, such as these if we need 2K code ROM, data RAM having 128, data EPROM 128, and pins 15, timers 2, then these are the pin numbers and packages. So these are some groups, and it's also like 80 you use for Admiral. Depending on these features, we are selected, such as mega we selected, and these are its packages and pin numbers. So all the our micro AVR microcontrollers are just like this. We can easily get all of our information from its data sheet. So it's just like this. If we touch in its physical form. So these are some its group: classic, mega, tiny, depending upon its features. Now you can see these are the some name of AVR microcontrollers, such as 80 mega 128. 80 means Atmel mega group, and 128 denotes flash. So tiny names as a tiny group, 904 names as a classic group, and 80 stands for Atmel. So this is about the basic introduction about our AVR microcontrollers and our basic introduction to the internal architecture of our AVR microcontrollers. Jazakallah.